Welcome back, ninth graders. Go ahead and grab a pen or a pencil, grab a piece of paper or a notebook, and get those thinking caps turned on for the last week of Barso ASAP for now. What we're going to be covering today is systems of linear equations. Big phrase. Now, just like we've done with every topic, we're going to break down what this means. So, a system. What is a system? You might think of a system as a machine. You might think of a system that we have at a Barso, a moving connection of parts that come together to serve some purpose. A system in mathematical terms has an even more basic meaning. A system of equations is two or more equations that share variables. An example would be 2x plus 3y is equal to 8 and y equals x minus 2. A counterexample, something that would not be a system of equations, would be z plus w is equal to x and a plus b is equal to c, because they do not share variables. All right, so the reason that we're using systems of linear equations is when we have two unknowns. So as an example, if I'm trying to find x and y in the equation x minus y is equal to negative 3, well, we know x minus y is equal to negative 3 forms a line. There are an infinite number of potential solutions. But if I involve a second equation could actually bring me a solution, because almost all second equations, if we graph them, are going to look like this. Now, going back to our example of x minus y is equal to negative 3, let's try to bring up a second equation. 3x plus 2y is equal to 16. Now, with this second equation, we are able to find an intersection point. As you can see, the intersection point is where x is equal to 2 and y is equal to 5. And in a minute, we'll see some strategies to find out exactly how to find that point in a system of equations. Now, is it possible that two different equations would not intersect, would not form a solution? Take a minute, jot your answer down, and we'll bring it back in a second. So I hope you came up with the answer that no solution would be possible if the two equations were parallel to each other. If one equation is parallel to the other, they're going to continue going on for infinity without ever touching each other. So that would be one situation where you could have a system of equations with no solution. Now, one more question. Is there a situation where you can have two equations that are having an infinite number of possible solutions? Pause the video and give it a try. Now, the one way you could have two equations that have an infinite number of solutions is if the two equations are really the same equation written in two different ways. So if I have the equation x minus y is equal to negative 3, what value could I put into the equation y is equal to x plus blank in order to get an infinite number of possible solutions? Pause the video and give it a try.
So in order to find which equation would give me a system with infinite solutions, I can rearrange the first equation. First, I'll subtract x from both sides, and I get negative y is equal to negative x minus 3. And then I can multiply both sides by negative 1, giving me y is equal to x plus 3. So plus 3 would be the constant that I would need to add to the second equation in order to essentially mirror the first equation and get an infinite number of possible solutions.
So now we're going to show you two main strategies to help you solve two system equations. The first one is substitution. In this method, you isolate a variable in one of your equations and plug that relationship into the other equation. This will provide you with an equation with only one variable, meaning that you can solve for the variable. Once you know the value of one variable, you can easily find the value of the other variable by backsolving. Let's try with an example. X minus 7y is equal to negative 11. 5x plus 2y is equal to negative 18. Now if we try to solve we can begin to isolate x. So x minus 7y is equal to negative 11 can be turned into x is equal to 7y minus 11. Now we can plug in x for the x in the second equation. And so we get 5 times 7y minus 11, close parentheses, plus 2y is equal to negative 18. Now if we distribute the 5, we get 35y minus 55 plus 2y is equal to negative 18. Now we've got a one variable equation, and we can solve to get y. So we get 37y is equal to 37, y is equal to 1. Finally, plug y is equal to 1 into one of the equations, and x is equal to negative 4. Now sometimes the substitution method can be difficult to apply, so using elimination becomes a better method. In elimination, you will eliminate a variable by adding the two equations together. To do this, you'll have to multiply one or both equations by a value in order to eliminate a variable. Once you have added the equations and eliminated one variable, you'll be left with an equation that has only one type of variable in it. And we know how to solve one variable equations. Let's give it a try. 6x minus 5y is equal to 8. Negative 12x plus 2y is equal to 0. So for the solution, what we can do is we can do 6x minus 5y is equal to 8 times 2 is 12x minus 10y is equal to 16. And now we have a positive 12x in the first equation and a negative 12x in the second, so those will cancel out when we try to add them together. Finally, 16 plus 0 is just 16, and negative 10y plus 2y is equal to negative 8y. So we're left with negative 8y is equal to 16. Y then is equal to negative 2. We plug in x, and we get x is equal to negative 1/3. Now that we've practiced a system of linear equations problem algebraically, let's try it in a word problem form. A total of 78 seats for a football match are sold, producing a total revenue of $483. If seats cost either $2.50 or $10.50, how many $2.50 seats and how many $10.50 seats were sold? Go ahead and pause the video and give it a try. Alright, so the first thing that we're going to need to do is identify what the two equations are. So our first equation is going to be about the total number of seats compared to the two different types of seats that we have, which we can label as the x seats and the y seats. Now the second equation we're going to set up is about the revenue. So the x seats, we can say, are worth $2.50. The y seats are worth $10.50. And so our equation can be set up as 2.5x plus 10.5y is equal to our total revenue of $483. Now, we can multiply the second equation by 10 to clear the decimals. So that becomes x plus y is equal to 78, and 25x plus 105y is equal to 4,830. Now, we can solve the equations by multiplying the first equation by 25 and subtracting it from the second. So we're left with 25x minus 25x is equal to 0x, and 105y minus 25y is equal to 80y. Finally, 4,830 minus 1950 is equal to 2,880. Y then is equal to 36. Finally, we plug in, and we can do x plus 36 is equal to 78, and so we subtract 36 from both sides, and x is equal to 42. Thus, 42 of the $2.50 seats and 36 of the $10.50 seats were sold. Alright, ninth graders, today we reviewed systems of linear equations, specifically defining what a system of linear equation is, what are some different strategies to solving them, specifically substitution and elimination, how they appear graphically, and what are the different ways that we might encounter them, such as in a word problem. Alright, don't forget this is a 9th grade competency. If you want to move on to 10th grade math, you need to have mastered this skill. It has been a pleasure to make these videos. I am very happy that I've been able to wield a skill that I am passionate about to help provide some educational content and some friendly faces while we are unfortunately meant to be apart at this time. My thoughts and wishes are with you in Somaliland. I am very excited and cannot wait to get back to see you all. Please keep studying, keep up the tenacity, and all the things that you know make us proud to have you as students.